Okay, so given the function f of x equals 5x minus 3 over 2 minus x, determine the equation of the tangent to the graph of f of x at x equals minus 5. So our first step is to compute the limit. So the slope of the tangent is equivalent to the limit of the function as h approaches 0. So we sub in our x value into these x values here, and we get this line. We then sub in our function notation into the function given. So that provides us with this line. After that line, we further simplify by distributing, and then simplifying again, and again. And then we take our common denominator of this fraction and multiply it into the numerator of this one and the denominator of this one. That leads us on to further simplifying and canceling out the 28s and canceling out the h's. So at this point, this is as far as we can go for simplifying. So we can then assume that h approaches 0. So this is what this notation is. It's just an arrow going through the h with 0. So then we can find the limit, which is equal to 1 over 7, which is also the slope of the tangent. So the second step is to find f at negative 5. So this is a quite simple calculation in which you just take negative 5 as your x value and sub it into the x variables within the function. We find this value to be minus 4. So our third step is to solve for b, the b value in the equation of the tangent. So we get this equation from the same equation for a linear function from grade 9 math, y equals mx plus b. But the only difference here is that your slope value, your m, is the slope of the tangent, mt. So we take our minus 4 that we found earlier from the function and sub that into y. And we do so for the slope of the tangent as well. So that would be 1 over 7. We sub in our x value given in the question, minus 5 again, and we're isolating for b. So we move this over to the left, and then you flip it. So the b is here, and then I just flipped it over there. You can do your common denominator, and then you find the b value to be minus 23 over 7. At this point, the question's practically done, and the last thing to do to get full communication marks is write a therefore statement. So I just wrote that, therefore the equation of the tangent on the graph of f of x at x equals minus 5 is y equals 1 over 7x minus 23 over 7. And that's how you would do question 1. Question 2. Rationalize the denominator of this fraction and fully simplify it. So to fully rationalize something in the denominator, we don't want any roots in the denominator. How do we do this? We multiply by its conjugate pair. But if we just multiply by its conjugate pair, that would change the actual value. And we don't want that. We want the same numerical value in the calculator. So what we do is multiply by 1. So notice that these are the same. So technically, this bracket here is equal to 1. I mean, not technically, it is. So all we have to do is multiply by its conjugate pair over its conjugate pair. And we simplify that by distributing this in. These two become a difference of squares. Although it's a little bit more complicated than we're used to from advanced functions, the a and the b values are actually 7 root 2 and 3 root 8. And then we further simplify and further simplify. And most students would come to their final conclusion that that is as simplified as it gets. But in fact, this is actually wrong because most students forget to check that root 8 can be further simplified into 2 root 2, thus making that 45 times 2, making it 90 root 2. We can then further simplify this by factoring out root 2, so it would be root 2 times 195. And then we can reduce the fraction into 15 over 2 times root 2. So this would be the fully simplified answer, and it would be correct because it rationalized the denominator, so we don't have any roots in the denominator, and it can't be further simplified with a calculator. Question 3. Create the equation with restrictions and the graph of a piecewise function f of x with the following properties. So the first property is the domain. We want it to equal minus 10 and go all the way to 12 and also equal that. That's interval notation if you haven't seen that before. And B, we want the limit of f of x as x approaches 5 from the left. That's what the little minus sign after the x approaches 5 means, from the left, to equal minus 4. C, so we want the limit of f of x as x approaches 5, but this time from the right hand side, so that's indicated with a little plus, to equal 2. And D, we want f of minus 3 to equal 1. And E, so we just want the function to consist of two different equations from different families of functions. So linear, quadratic, cubic, square root, exponential, sinusoidal, whatever you would like. So step 1. So step 1 has two parts, A and B. So the first part would be to find the m value, the slope, from the context of the question. So the question isn't very direct, and it's going to ask you to basically figure out information on your own. So from D, we can find that the x and y values give us 1 point. And from another point, we can find that this limit gives us an x and a y value. So that's that point. From that, we can then calculate the m value, and we figure that out to be minus 5 over 8. And part B is just to find the linear equation of that. So quite simply, we just use y equals mx plus b, sub in our values, solve for b, and restate the equation for our proper domain. So, step 2, we find a function that is within the info given. So since we've already used a lot of the information, we can narrow that down. We have used this, we have used that part, the minus 10 to 5. We have used this part, and this is irrelevant. This is just to pick 2. So from advanced functions, you should be pretty comfortable with finding a function that meets a certain database, a certain restriction or something. So basically, from this, we know that the limit of f of x as x approaches 5 from the left-hand side, from the right-hand side, my bad, equals 2. So as you can see, I chose a square root function. So if we go closer and examine this on the graph, as we approach x equals 5, this mark, right here, on the function, from the right-hand side, we approach the value of 2. That's 2. And even though there's a hole there, it doesn't matter because limits do not count holes. They just count as if where it was gonna go. And of course, the limit cannot show any of this because that's jump discontinuity, but you get my point. So then you can show some table of values for subbing in the function. So I showed one of them, and then you find these values. And you just plot the points and connect the dots for this domain. So that's the rest of the domain. So we were at 5, we've already finished 10, and now we needed to go to 12. So it equals 12 and goes close to 5 with a hole. So that's the domain. And step 3 is just state the piecewise function in a therefore statement. So therefore f of x equals this equation on this domain, as well as this equation on this domain. And that corresponds with the graph, of course. So some students lose marks in communication on where they put the holes and the solid dots. So be sure that when you're stating that the function hits that point, it needs to be a solid dot. So notice that this value is minus 10 and this value is 5. I've specified that in the interval notation in the piecewise function. So it hits minus 10 and it hits positive 5. So, and with the other one, I use the round bracket interval notation to say it just goes super close. And the square bracket to indicate it hits that mark. So as you can see, I've indicated with the hole at 5, positive 5, that it just goes super close. It does not hit. And with 12, I know it's off the graph, my bad. I've indicated that it hits that point for sure. And some of you may ask, how should I know to put a hole there? And the reason for that is that it doesn't really matter where you put the hole, but you have to have a hole and a solid point. Because if you were to fill this point in, so let's say, I'll just fill this in for now, this wouldn't make any sense and you would get marks deducted because a function can't be in two places at once. On the dashed line that I drew, x equals 5, you can't have a function that hits that point, that hits that line twice. It just doesn't mathematically make any sense. So that's why I chose the hole to be in the square root function. You can choose the hole to be in the linear function and have a solid point in the square root function at 5. Either way is fine. So that's how you would answer question 3. The piecewise function, just state it like this with the open squiggly bracket. Don't close that bracket and comma the domain restrictions. All right, hopefully you liked my solutions and hopefully this helped you with any schoolwork. Just to let you know, these are real evaluations that I have done. So they're not just some made up questions that are probably never going to be on a test or anything. They are real questions and they are with real marks, those associated marks that my teacher had put with these. So yeah, so that's that. So if you guys have any questions, just put them in the comments, like and subscribe, please. Thank you.